Welcome back to the Punny Math Teacher. So remember, today's expectations are to use twice this video's length to take notes, wonder, think about questions, send us questions, etc. in comments. Remember, these notes are for your future self. So if you remember it now and you understand it, awesome! But make sure that yourself in 2 hours or 24 hours or in 2 weeks understands what the concepts were and how to use them to build onto other concepts. So pause, rewatch, change playback speed, put on closed captions if that's a thing. I don't know if I'll actually enable that, so and they may not be the best closed captions. And then remember, the Google site there is my website that has extra resources for you as well. So my goal is that my hair is up, so it shouldn't interfere with the mic in any way, so we should be good for audio. And let's get going. So our objective today will be to apply the less than sign and the greater than sign correctly and be able to interpret one variable inequalities. And then we'll come back for our comprehension questions later. So again, we are working with our table of contents. This is a new unit, so there are only 2 videos in this unit. It's really short and sweet for inequalities, and our next unit is also short and sweet on exponents. So we're working with one variable inequalities, page 17. So head that up and let's go. All right, so before we start, I do want to put something in our margin. I'm going to put these symbols. So I'm sure you've grown up with it always eats the larger number, which that is true, but the symbol itself has a name. So if you think about it, how many points did I just draw? 1. How many points did I draw over here? 2. And this is a true statement. 1 is less than 2. So when you draw the less than sign, you are drawing a statement of 1 is being less than 2. That's why this is that symbol. We can do the same thing on this one, which you know the symbol already, but 2 is greater than 1. So by drawing this symbol, you can remember which one is which. You don't have to have 2 numbers and think about, okay, it always goes towards the larger one. Well, that's how to properly write it, but that's not how to remember which symbol is said how. Okay, so we're now going to make a 3-column chart for the majority of our notes. So our first column will be using the symbol. Our next column will be what is the inequality that we're using. And we are going to be graphing these. Now we're graphing these on 1 number line. Later we get into 2 number line or 2 variable graphing. Right now we're working with 1 variable. So it's 1 letter that stands for a value that could change. That's why it's a variable. It could change. So our first symbol will be the less than sign. So this is the less than sign. And an example of an inequality is B is less than 4. Say that out loud. B is less than 4, which means when I graph this, this is a number line for any number that B could be. So I'm going to put a 0 there. That way I can see my negatives to the left and my positives to the right. The only number I care about, though, is 4. That's a positive, so I'm going to put that on the right-hand side. Scale doesn't matter. It can go by 4s, totally fine. Now, any number that's less than 4 can be on this number line. And I'm going to use a different color. I'm going to use green just so we can see the graph differently than the number line. If you're using a pencil, I'm going to be using a squiggle line. That way we can see the difference. If you're using a pencil, you can always shade it darker or use a squiggle. Both work. Move the camera there. Okay, so on this graph, I want any number that's less than 4. Is 4 less than 4? Nope. So I'm going to put an open circle at 4 because that's telling me 4 is not a solution. It's not less than 4. If I wrote 4 less than 4, that would be false. Okay, and I'm going to test 0 because it's the other number here. Is 0 less than 4? True. And that means I can shade all the way to the arrow everything to the left of 4. Because -1 is less than 4, 1.23579 is less than 4. All these numbers to the left are less than, 4 is not less than, and all the numbers to the right are not less than. And this open circle that we drew means no value. or no solution. That 4 is not a solution to our inequality. All right, so we're going to speed things up a little bit because the next one's really similar. It's the less than or equal to. And now you're wondering, wait, these are inequalities. They're supposed to be not equal symbols. Well, this allows for it to be equal, but it also allows for our values to not be equal. So my example is f is less than or equal to 8. I'm going to have my number line, 0 and 8. I'm using the 0 just so I can tell the difference and have a border between my negatives and my positives. Since 8 is positive, I'm going to stick it on the right-hand side. Is 8 a solution? If I plug in or substitute 8 for f, is 8 less than or equal to 8? Yeah, it's equal. So I'm going to have a closed circle and then shade to the left because those are all the values less than 8. And the equal to tells me that it's a closed circle. So this closed circle means it has value. Alternatively, you could say this is a solution. 8 is a solution because we're allowing the variable to be equal to that 8. It doesn't just have to be less than. All right, now we're getting into our next ones. I'll move my mouse out of the way. There we go. So our next ones, I'm sure you've assumed what they will be is greater than, and we're going to use a is greater than 5. Can you graph this on your own? Pause the video, try it out. Is it going to be an open or closed circle? How can you tell? It's going to be an open circle because there's no line underneath. This is not an equal to. This is just a strict greater than. And so I'm going to shade to the right. All those numbers, 6, 7, 9, 11, 123, all those numbers to the right are greater than 5. All right. And then my next one will be greater than or equal to. And we're going to use z is greater than or equal to -7. So this is our first time with the negative. Try to graph this one on your own. All right, so I have a -7. It doesn't have to be by a scale. I just know that somewhere to the left of 0 because it's a negative number. I know it's also going to be a closed circle because it has value, and I'm going greater than. So it's actually going past the 0. Notice that 0 was not a solution on this previous one, so that's why it's not being shaded. And we have one more, and then we have a little tiny cross section at the bottom. Okay, so our last one is the strictest inequality of them all because it's literally not equal to. So this one is not equal to. And it's going to be s is not equal to -3. So I'm going to draw my graph, have a 0, have a -3. What do you think this graph is going to look like? Any number that's not -3. So that has to have an open circle because there's no value, it's not a solution, but every other number is. So everywhere else on our number line will be colored except for that 3. All right, now I do want to show you a little shortcut, that pattern you can see. So order matters. If you've noticed, as we go through all of these examples for inequalities, order matters. We used our variable first, then we had our symbol, then we have our constant. Now, yes, you can write these in a different order, but keeping it in this order is actually really helpful. So order does matter to be able to use the next shortcut. So on our shortcuts, look at this one. So actually, I'm going to use a blue pen. Now we have a third color here. So you have a variable, a, you have your symbol, greater than, and you have your constant, 5. 5 is 5 no matter what. It's a constant. It's not going to change. The value of a could change. A could be 6, it could be 7, it could be 123. So this is a is greater than 5. Notice that this greater than matches this arrow to the right. So it's telling me to shade to the right. But what if I had switched the order? What if I had written it as 5 is less than A? These are the exact same inequality, but I can't trust this symbol to tell me which direction to shade. So it's really helpful to flip everything so you can see it. Now, when you flip everything, you have to switch both sides, so A and then 5 gets switched, but you also flip the symbol. So this, instead of being a less than, turns into a greater than, or vice versa. And if you don't trust me, plug some numbers in. So if 6 is greater than 5, that's true. Is 5 less than 6? That's true. So both of these are the same set of solutions because they're going to be the exact same graph. All right? So we're going to look at that a little more just to make sure you have the words here. So if I say 11 is greater than B, this is saying that is my inequality. I'll draw an arrow. 11 is greater than B. I could also write B is less than 11, which tells me this. Both of these are the same. So remember, if you want to trust the symbol to graph it, so I would actually use this second one to graph it. I'd have a 0, I'd have 11. I know it's going to be an open circle, and I know I can trust it because it's variable, symbol, constant. So I'm going to shade to the left. So if you have the same color like a pencil, I would do a squiggle and then make sure you go all the way to the arrow. That way we know it's all the way down there. It's not just part of the way of the number line, it's all the way down there. All right. Hey. Okay, comprehension questions. Which inequality symbol represents this situation? Eating at least 5 slices of pizza or buying at most 3 purses. How do you remember the differences and why is it that symbol that you said? And then write down the steps you use to check your inequality graphs. How do you know to shade to the left or to the right? And make sure you make that note to yourself because you're the one reading your notes. So in the future, you know what you're doing. All right, have a great day and thanks for watching.